Hey guys, I wanted to talk to you about the last FRQ that we took. And if you remember correctly, it talked about trichomes, which are hair-like structures on plants that are thought to provide protection from the plant being eaten. And so there were three populations, three different outgrowths of plants, and there were 6 plants in each of the population that were measured. They measured the number, or they counted the number of trichomes per centimeter squared. And so in population 1, the first plant had 8, the second plant had 11, so on and so on. And so the mean of that whole population was 9. The mean, or the average, of the second population was 11, and the mean, or the average, of the third population was 14. And so what they asked you to do on the axes provided, create an appropriately labeled graph to illustrate the sample means of the 3 populations. So here we have the 3 populations. And so we have 9, and we have 11 for our second, and we have 14 for our third. And now what they want us to do is to illustrate the sample means of the 3 populations to within 95% confidence. And so I think this is where we need a bit of an explanation. So what are confidence intervals, and what is a 95% confidence interval? To do that, I'd like to jump around a little bit into an example about something random, the height of females in the United States. So a few concepts I want to introduce to you. First is the normal distribution curve. And so this is a normal distribution curve, if you can see here. And all this is saying is that, that there's a mean, or an average, and the average height of females in the United States, it's actually 5'4", but for the sake of ease in this demonstration, we're going to use 5'6", or 5.5 feet. So right here, this is our mean. And so what we're saying is that the average height of females in the United States, you're going to have more data points in those places, or you're going to have more females. So here we just have more females that are 5'4". And if you're to go a little bit shorter, you're going to have slightly fewer. And if you're to go a little taller, you'd have still slightly fewer than the mean. And as you go even shorter and shorter, you're going to have fewer and fewer until you have very, very few. And then you have your random outliers. And so that's your normal distribution curve. And so to find a confidence interval, what we're looking at is how confident are you that somebody's height is going to be within 6 feet. Let me go to a different color. How confident are you that somebody's height is going to be within 6 feet and 5 feet? So here, I'm not very good at drawing with this thing yet. 6 feet and 5 feet. And we're going to say that, because we're going to be learning about the 68, 95, 99.7% rule. And so here, if this is our first confidence interval, so this would be a confidence interval this way, and then this is a confidence interval that way. So this is our first confidence interval, and we would say that 68% of the females in the United States are going to fall within this distribution curve. So if you were to walk down the street, or within these boundaries of these confidence intervals. And so if you were to walk down the street and find the height of a random female, there's a 68% chance that she's going to be within this range. And so if we go out a second confidence interval, here, let's go right here, then we will see that, let me see, I can do green. Our second confidence interval, we would say that 95% of the females are going to fall within that range. Or we would say that if you were to walk down the street and find the height of a random female in the United States, there was a 95% chance that she would fall somewhere under this entire curve. And so if we were to go out a third confidence interval, let me go to blue. here. And these are definitely not true to life. These are just random numbers. This we would call 99.7, our third confidence interval, 99.7. If you were to walk down the street and find the height of a random female, there's a 99.7% chance that she's going to be within the range of 4 feet and 7 feet. Do we have some random outliers? Is there a 0.3% chance that they might be below 4 feet or above 7 feet? Yes. But most of our data is going to be within this range, our 99.7, or within our 3 confidence intervals. And so where do we put these confidence intervals? How far are they from the mean? How far are they from this original line? So are we going to be 5 feet from the mean, or are we going to be just a few inches or a few centimeters? Well, that is a calculated quantity, and that is going to be given to us. So if we look at our problem, that was given to us. Our standard error of the mean was our standard deviation, and they said that it is 1. And we're going to signify this with a sigma. That's our standard deviation, and so 1. If they wanted 1 standard deviation, they wanted 95% confidence, and so we're going to go 2 standard deviations. 1, 2, 1, 2. Let's go back and look at what that looks like on our distribution curve here, our normal distribution curve. So let me erase this mess. So here we have, keep erasing. So here we have our first standard deviation is a half of a foot. So that's calculated, that's given to us. And so we're going to write that our first standard deviation to taller is at 6 feet, and our first standard deviation to shorter is at 5 feet. And so therefore our first standard deviation is 68% of our population. And so, but we're looking for 95% confidence. And so that's another, so if our standard deviation is going to be, so 2 standard deviations is going to be 1 whole foot. And so let's do that. So if this is a half a foot, well then here's a whole foot. And so this right here is our 95% confidence. So let's look at our trichome density, a graph of our trichome density. So on the bottom of this, we have the number of trichomes. And here you can see I have labeled where all of the data sets, the data points are from the first question. And so we have 6 trichomes per centimeter squared, and then 2 at 8, 2 at 9, 1 at 10. And so our mean, which we know from the data set, is 9. So this is our mean. And they gave us our standard deviation, which was 1. And so if we wanted to know with 68% confidence, we would have drawn a line here and drawn a line here. So that if we were to pick up a trichome, we would be 68% confident that the number of trichomes on the plant will fall within this range. So I'm sorry, if we were to pick up a plant and count the number of trichomes, the number of trichomes would fall within this range. So that would be 68% confidence. But we're looking for 95% confidence. And so we're going to go 1 more out, since our standard deviation or our standard error is here. We can say that 95% of our data is going to fall within this range. And so we have 1 data point out here that is not within that range, but we could say that with 95% confidence, that is where our trichome density would be. And so let's look at how we graph this. Here we said that there was 9, our mean was 9, and that here, so our mean is 9, and that to be within 95% confident, and our standard deviation is 1, we would need to go 1, 2 up and 1, 2 down. Let's do one more. If you totally get this, then go ahead and click out, but we're going to do the second mean here, which was, or the second population. We said that the mean was at 11. And so here, if our mean is right down the middle here at 11, here's our normal distribution curve. And we want to know with with 95% confidence that if we were to pick up a plant and count the number of trichomes on it, that it would fall within this range. So we said here and here. So with 95% confidence, so including these, 1, 2, 1, 2, yeah. And so here, if our mean is 11, then we should have our lines on our graph up here at 13 and 9. Let's see if we go up. Yep, we have 13 and 9 right here. So let's go on to our second part of our question. Based on the sample means and standard errors of means, identify the two populations that are most likely to have statistically significant differences in the mean trichome densities. Meaning which one is being exposed to an environmental factor and one is not. What is the likelihood that one absolutely is and one isn't? And so if we have 3 populations, we could say that population 1 and population 2, there's a small difference, but because let me get my pen to work, but because the standard error of mean lines overlap, we can't say for certain, we can't say with confidence that population 2 is being exposed to an environmental factor that population 1 is not. But we can say with confidence that because these two lines, population 1 and population 3, their lines don't overlap. In fact, there's a space apart. We can say with confidence that there is a factor that is affecting the number of trichomes that are present on a plant. I think that everything else for this FRQ is pretty straightforward. So I'll put both of these, the answer key and this explanation, on PowerSchool so that you can go over this. And then I will put another FRQ on PowerSchool for homework, and we will go over that next class that I see you guys. I hope that you have a great, healthy weekend.